Greetings all. I am Dr. Suresh, Assistant Professor, PG Department of Computer Application, St.Joseph College of Arts and Science, Autonomous, Cuddalore. In this presentation, we will deal with white box testing, which belongs to the type of testing. White box testing is a technique in which the software's internal structure, design, and coding are tested to verify the input and output flow and improve the design usability and security. In white box testing, the code is visible to the tester. White box testing can also be called as clear box testing, open box testing, transparent box testing, code-based testing, and glass box testing. First, we will discuss about the classification of white box testing. Generally, white box testing is classified into two categories, namely static testing and structural testing. Static testing is again subclassified into test checking, code walkthrough, and code inspection, whereas structural testing is classified into unit or code function testing, code coverage testing, and code complexity. Code coverage is again classified into statement coverage, path coverage, condition coverage, and function coverage, whereas code complexity deals with the cyclomatic complexity. Now we'll discuss each and every aspects of white box testing in the next slides. First, we'll deal with static testing. Static testing is the testing of the software product works manually, but they are not executed. It starts early in the life cycle, so it is done through the verification of process. Static testing does not need computer, as the testing of program is done without executing the program. For example, previewing, walkthrough, and inspection, etc. are the types of static testing. The code generally is tested here without executing the program. The code is checked for verification by the developer. The different types of static testing are test checking, code walkthrough, and code inspection. First is test checking. Test checking is a method to verify the portions of the code for correctness. This verification is done by comparing the code with the design to make sure that the code does what it is supposed to do. To check whether the code is performing what it has to do. Test checking is done by the author of the code. It is usually done by the developer who has written the code, who has developed the code. Code walkthrough. In code walkthrough, the author guides the review team via a document to fulfill the common understanding and collecting the feedback. Walkthrough is not a formal process like code inspection. Walkthrough is useful for higher level documents, that is requirement specification or architectural documents. Walkthrough is used to check the requirement specification and architectural documents. The next is the code inspection. Here the trained moderator guides the inspection. It is the most formal type of review. The reviewers are prepared and check the documents before the meeting. When the product is examined and defects are found, these defects are documented in an issue log. The next comes the structural testing. The structural testing is the testing of the structure of the system or component. In structural testing, the testers are required to have the knowledge of the internal implementations of the code. They should have some knowledge of the code. So in this, the first thing is unit or functional testing. The initial part of structural testing corresponds to some quick checks that a developer performs before code testing. Initially, the developer can perform certain tests by knowing the input and output variable. For modules with complex logic or conditions, the developer can build a debug version of the product to make sure the program is passing correctly. Next is a code coverage testing. Code coverage testing is made up of 4 types of coverage. They are statement coverage, path coverage, condition coverage, and function coverage. Now we'll discuss one by one. The statement coverage. The program consists in most conventional programming languages can be classified as sequential control flow, two-way decision statement, multi-way decision statement, loop like while, do, repeat, etc. Statement coverage refers to writing test cases that execute each of the program statements which have been listed here. Path coverage. This coverage is used to ensure that every possible path is executed and tested. Every independent path is considered under basic path coverage. Path coverage provides a stronger condition of coverage than statement coverage. Condition coverage. Path coverage testing is a type of testing that is not sufficient during all the time. It is necessary to have test cases that exercise Boolean expression and should have test cases that test the true as well as false conditions as well as path. Condition coverage is dependent on one another. If it is true, it has to check the false path, and if it is false, it has to check the true path also. Next comes function coverage. Functions are easier to identify in a program, and hence it is easier to write test cases to provide function coverage. Functions are at a much higher level of abstraction than code, so it is easier to achieve 100% of function coverage. The next comes code complexity. In code complexity, we are going to check only one type of testing, that is called as cyclomatic complexity. Cyclomatic complexity is nothing but it is the quantitative measure of the logical complexity of the program. That is, the logical complexity of the program can be measured with the help of this cyclomatic complexity. It can be done with the following step. It is a software metric used to indicate the complexity of the program. It indicates how the complex the program is. To understand the complexity of the program, we have to calculate the cyclomatic complexity of a program. So McCabe proposed a cyclomatic number V of G of graph theory as an indicator of software complexity. The cyclomatic number is equal to the number of linearly independent paths through a program in its graph representation. For a program control graph G, cyclomatic number V of G is given as V of G equal to E minus N plus 2, where E is the number of edges in the graph G and N is the number of nodes in the graph G. So a flow chart is converted to a flow graph, and with the flow graph we can calculate the number of edges and the number of nodes in the graph. A flow chart can be converted into a flow graph, and in the flow graph we can note the number of edges and number of nodes. So with that we can calculate the cyclomatic complexity of a program. Cyclomatic complexity can easily reveal the logical complexity of the program. Nothing but number of independent paths that can be executed or how many paths are there to be executed will be disclosed with the help of cyclomatic complexity. That is V of G equal to E minus N plus 2. There are other methods where we can calculate V of G that can be dealt later. So these are some of the properties of cyclomatic complexity. V of G is the maximum number of independent paths in the graph. For example, a graph contains 4, V of G is 4 means there are only 4 independent paths in the program. So all that we have to ensure that all 4 paths have been executed. V of G should be greater than 1. V of G always should be greater than 1. So then only we can make sure that the path has been executed at least once. Next, G will have one path if V of G equal to 1. V of G is 1 means we can understand that there is only one path to be executed and minimize complexity to 10. In any program, we should make sure that the complexity, cyclomatic complexity should be 10 or less than 10. This reveals the complexity of the program. Thank you.